Scenario. A rope is wrapped around the circumference of a solid disk of radius r is equal to 1.2 meters that is free to rotate about an axle that passes through its center. The force applied to the rope has a magnitude of 2 newtons that is tangent to the edge of the disk for 1 second. Question. If the disk starts from rest, what is the angular velocity after 1 second? The answer. The approach is to use the kinematics equation. Omega is equal to the initial omega plus the angular acceleration times time. The issue now is that we need angular acceleration, alpha. To get alpha, we can now take a look at the torque equation. There are two torque equations here. Torque is equal to radius perpendicular times force, and torque is equal to the rotational inertia times angular acceleration. Notice that the angular acceleration can be solved here because we have these two equations if we set them equal to each other. So I alpha is equal to radius perpendicular times force. This is when the two torques are set to each other. Now we can solve by dividing the rotation inertia to the opposite side. Now we get the alpha alone. The angular velocity value cannot be determined without knowing the rotational inertia of the disk, which is I. There was no way we could get the alpha without getting the I, and we can't get the alpha to plug in here to get that angular velocity of omega. So the I is the issue. This is why the next question says, given the rotational inertia is 0.8 kilograms, find the angular velocity after 1 second. Normally the rotational inertia has a really weird equation, but for the AP Physics 1 test, they will actually just give you the rotational inertia, so you don't have to calculate it by yourself. So now that we have rotational inertia, we can actually plug it in to this equation to get the angular acceleration alpha. Plug it in, 1.2 is the radius, 2 was the force, rotation inertia is 0.8. Now you get a value for it. The unit for angular acceleration is rads per second squared, which is 3 in this case. Now we can plug it into your kinematics equation. Notice that the initial angular velocity was 0 because it says the object started from rest. Plug it in, we can see that the angular velocity is 3 rads per second. The last question is, how much did the circumference of the disk rotate for? Again, the approach is to use the kinematics equation. We already used one of them. The key here is to understand what circumference means. The circumference is basically the distance traveled in the circle world. So you're going to use the theta value. This is the theta is equal to angular velocity initial t plus 1/2 angular acceleration t squared. This is the quadratic version of the formula. We can now plug things in and we can now get the value of 1.5 rads. The unit for the theta is rads because that's how much it's traveled. So here you go. This is the relationships between all the kinematics equation in the circle world that you can see on the exam.